Hello everyone, my name is Rajat Maurya. I'm pursuing BTech from Madan Mohan Malviya University of Technology in Electronics and Communication Engineering, and currently I am an intern at VLSI Expert Private Limited, and you are watching HSPICE simulation series. So this video is going to be in two parts. In the first part, we are going to see the concept of ground node, and in the second part, we are going to learn that how can we obtain schematic diagram out of a given netlist. So in the previous video, I have told you that how can we write a netlist of a given schematic, and here is that schematic diagram, and this was the netlist that we wrote. So let us just run this netlist using HSPICE command and see what will happen. Let me just get out from this VI editor. Yes, so I'm going to run the command for the HSPICE simulation, and this was the command that I have told you in the first video. So I'm pressing enter. So this time it is showing that HSPICE job aborted. It means that we have some error in our netlist code. So we are going to figure out that what is the error and how we can fix it. If you remember, in the previous video, I have told you that after running the simulation, HSPICE is going to create some output files. So if we want to check any errors or warning, so we have to open a specific file created by the HSPICE after the simulation in which it mentions all the warnings and all the errors. So let us find out which file it is. So I'm just going to list all the files in this folder. So this file with the extension .lis is the file in which we can see all the errors and the warning. So let us just open this output.lis file. So in this file, we are going to see where it has mentioned the error. Yes. So as we can see, it is showing that no connections on ground node. But how it can be possible? Because in the netlist, we have specified that this C is grounded and all the connections were up to the mark. So why it is showing that no connection is to the ground node? See, in NetSpice, uh, there is a concept of ground node. So if we write, let me just switch to pen. So if we write 0, GND or GND exclamation, only then the HSPICE would be able to understand that there is a ground connection in a circuit. Whereas the code that we have written, there is no mentioning of 0 GND or GND exclamation. So we have to make appropriate changes in our code. So let us just open our code once again. So I'm going to open the code again. So here you can see that we have mentioned a node C, which in our schematic is grounded, but without mentioning 0 GND or GND exclamation, the HSPICE would consider C as a normal node without any ground connection. So we have to rewrite this code and replace C with 0 or GND or GND exclamation. So let me just edit this code, and I'm replacing C with 0. And after saving the code, I'll be running it again. So I have made the changes, and now I'm just saving it, and I'm running the code again. So this time you can see that HSPICE job concluded. It means that this time our code has been run successfully. So this was the concept of ground node.
And remember that whatever circuit you are making, you always have to sketch a ground node in a schematic, and you always have to provide a ground node in every circuit and also mention it in the netlist as well. So ground connection is important, otherwise there will be an error. So now let us move upon our next part of this video.
We are going to learn that how can we obtain a schematic diagram from a given netlist. So as we can see that we are having two netlists over here. The first one is for RC low pass filter and the second one is for RC high pass filter. So although just looking at a glance over the netlist, one can say that both of them are same, but these netlists carry a minor difference of these just two lines. If you observe carefully, these two lines of these netlist are not same. Otherwise, all the rest of the code is same. So we are going to understand that how can this small change can lead us to to two different circuits. One can be RC low pass filter, and by doing small change, we can switch to RC high pass filter. So let us try to understand that how can we obtain them. So as I told you before, that netlist describes us that how are the components are interconnected throughout the circuits. So the whole task is to focus upon the components, their nodes, the values, and their connections. So we'll be just focusing upon the components. So let us take the RC low pass filter first. So in this netlist, all the components are defined under these three lines. So we can see a voltage source V1, a resistor R1, and a capacitor C1. So as I told you before that first of all we have to write the name of the component followed by the nodes, and the first node is always going to be the positive one. The second node is always going to be the negative one. So this 1 is the positive node and this 0 is the negative node. And at last we have to define the value of the component. So let us take all the component one by one. So first of all, let us take V1, the voltage source. So here V1 is a voltage source that is connected between the positive node 1, that is positive, and the negative node 0, which is sinusoidal in nature, having a frequency of 200 hertz with an amplitude of 1 volt with offset voltage to be 0. So let us draw V1. It is AC sinusoidal supply voltage having 200 hertz of frequency and 1 volt of amplitude. So this V1 is connected between a positive node 1. So let us just connect this to 1. We are calling this node 1, and a negative node to be 0. 0 is also ground. So just we are applying a ground connection here. So after this, uh, we have successfully established the voltage supply V1. So let's move on to R1. R1 is the resistor which is connected to positive node 1 and the negative node 2 with a value of 318.8 point 3 ohms. So let us connect a resistor. So it is a resistor. The name of it is R1 having a value of 318.3 ohm. So it is connected between a higher potential node of 1 and a lower potential node of 2. So through this node 2, C1 is connected. C1 is a capacitor, and then the negative node for the C1 is 0. So this is the negative node for the capacitor, and this is the positive node for the same. So here we have connected C1 having value of 10 microfarad. So as we can see that we have obtained the schematic of this RC low pass filter. So we can write over here RC low pass filter. So now let us move upon this RC high pass filter. We are going to repeat the same steps as we have just done over here. So let us take the V1, which is same for this case as well. So V1, and V1 is connected to the node 1 and 0, which is also grounded. So this is the node 0. But now the difference is that the capacitor is connected to the positive node 1. So we are going to connect the capacitor over here. And this is the negative node for the capacitor, that is 2. So this capacitor C1 have the value of 7 microfarad. And now this resistor is connected to the node 2 and 0. So we are connecting a resistor R1 through the positive node 2 and 0. So the value of this R1 is 546.7 ohms. So as we can see that this is an RC low pass filter, whereas this is an RC high pass filter. So we can visualize that just by just switching these two lines, or by just having small manipulation in these two lines, there can be a huge difference between the RC circuits or whatever circuits. So we have successfully made the schematic diagram out of the given netlist. I hope this video helped you to understand that how can we obtain a schematic diagram out of a netlist. If so, then please subscribe to our channel. And if you liked it, then give it a thumbs up and share among your friends. Thank you so much.